Hello guys, it's Uber system design. Designing the Uber system. Uber's technology may look simple, but when a user requests a ride from the app, or driver allows to take them from the destination. Behind the scenes, however, the giant infrastructure consists of thousands of services and terabytes of data supports each and every trip on the platform. Yeah, that's a huge infrastructure consisting of thousands of services. Webbacker System started out as a monolithic software architecture with a bunch of app servers and a single database. See, see, the architecture has evolved into a service-oriented architecture. It's now designed to handle taxis instead of it can handle taxi, food delivery, and cargo also. See, need to service a supply service and demand service. The supply service track cars using geolocation. Every cab which is active given sending latitude, longitude to the server every 5 seconds at once. The demand service tracks the GPS location of the user when requested. So dispatch system. It reduces extra driving, waiting time, global ETA. Let's see how the dispatch system works. The office is still hard to summarize and also the tiny cells using Google S2 library itself as a unique cell ID. S2 can give the averages for the sake to draw a circle to 1 kilometer radius center on London. S2 can tell what cells are needed to completely cover the shape. See, since it still has the ID is used as a starting key when a location is complete from the cell ID. The location is determined using the cell ID as a start key. The location of the supply is updated and sent to few replicas. See, a second robot at Google. Dispatch is built using Node.js. The advantage using Node is asynchronous and event-based framework. So to send and receive messages over WebSockets, anytime client can send the message to server, or the server can send and whatever it want to. See, BringPop is a library that brings cooperation and coordination to distributed applications. Also, that bring on top of membership protocol and provides request forwarding as a routing convenience. Listen. See. Apache Kafka is used as the data hub. Supplies CAPS uses Kafka's API to send accurate GPS location to the data center. Once the GPS locations are loaded to Kafka, they are slowly persisted to respective open nodes. Maps and routing of new area will define onboard new region to map and label with grids, verde. Rural and suburban areas less populated or traveled by Uber customers. So grade A, B, C highway corridors. Tiny cells, how Uber builds the map. Trace coverage, preferred access. How ETAs are calculated. Directly impacts ride matching and earnings. So the historical drive times can use AI simulated algorithms are simple. Discuss routes also to find the best route. driver as GPS location to predict traffic condition at any given road. So there may be cars on the road sending locations every 4 seconds. You can try this Casa source algorithm, which is foundation, and see the databases used. Oldest that were used in Postgres. Redis is used to a lot. Some are beyond Twin proxy. Some are behind a custom clustering system. MySQL database, Google's Bigtable, Simolis database, bunch of MySQL status, Simolis, save any JSON data without strict SEMA validation in Simolis fashion. Grip. SPTL data and Trips TV. The design goal is to handle a million GPS points right per second. For every write, I need to show at least 10 nearby cabs. GIS and Google S2 library. GPS location can be queried. Some Elasticsearch to do some log analysis. Track API, manage profile, collect feedback and rating, promotion, fraud detection, load balance. Yes, an application load balancing, IP and DNS based load balance, and based on IP address post trip actions. Once a trip is completed, the actions collect querying, send emails, object databases, schedule payments, price and surge. Surge supply and demand. By increasing price, more cabs will be on the road when the demand is more. There could be unexpected cascading failures. Network would fail. Whoever maintains a backup data center and switches are planned to route everything over to backup data center. Down to driver first. Now let's say there is data center failure, but the next time the driver's phone sends a location update to dispatch system, the dispatch system will detect that it doesn't know about the trip and ask them for the state digest. The dispatch system then updates itself from the state digest and the trip keeps going like nothing happened. Okay, so this Uber system Uber consists of when the user requests ride from the app and driver takes them to their destination. Yes. So their backend is designed to handle taxis. It can also handle taxi, food delivery and cargo. The challenging thing is to supply demand with a variable supply. Like it acts like a real-time market platform that drivers with riders using mobile phone. There are two services, supply services and demand services. This is how the backend works. Maps. They divide their maps and routing. They divide their regions into different grades. Let's see, and all the time. time is calculated using GPS location of various available vehicles. There is happening a lot of queries, and they use these as source algorithms for routing algorithms, and the database is used for Uvo is MySQL and some Semalis database. They use some kinds of Semalis database. Median GPS points lies per second. So they want to write million GPS points per second, and read is even more, as they need to show at least 10 nearby caps for every user. So they are using ZeroS and Google S2 library. So load balancing, these are done for load balancing. Post-trip actions, these are the post-trip actions. They use price as source. Well, I hope you learned something about Uber system design and how Uber works. Thank you for watching this. I hope.